So, we start up the session by discussing what are the different modes of fire protection. This part of the presentation will include a brief overview on active and passive fire protection. So, when I talk about fire protection, I am sure there are a few things which strike your mind right away. Some of which are fire extinguishers. I am sure you would that's one thing which you would have thought about when now that we are talking about fire protection. Smoke alarms, water sprinklers, and fire buckets. These are some things which we see in our common living spaces and which is something that we associate with when we talk about fire protection. These are called the active fire protection systems. They are called active protection systems because they jump into action during a fire, but then for them to function well in fire protection or for these protection systems to cut down the fire or to kill the fire will require a trigger signal. So, I will go back and explain to you with each example. So, let us take an example of a smoke alarm. In this case, the trigger signal here would be the smoke rising from a fire and causing a temperature rise in the sensors within the smoke alarms. Or for example, a water sprinkler, the trigger signal in this case would be again the temperature from a fire rising up to the sensor and then it is sending an information to the receiver, thereby triggering a reaction, which is the water being sprinkled in the place where there is a fire. So, if you look at all these examples, these include systems of fire protection which require a trigger signal to function. So, they work or they function in the case of fire in a very active way. So, obviously, if this comprises of all the active protection systems, the other kind of protection system is going to be called the passive protection systems. So, the passive protection system consists of methods which are through which we can contain fire and slow the spread of fire to the source of the fire. Yeah. So, if one kind of fire protection is called the active protection system, then the other kind is supposed to be called the passive fire protection system. On the contrary to an active protection system, in a passive protection passive fire protection system, it involves methods or attempts to contain fire and slow the spread through the use of fire resistant walls, floors and doors. For example, if we know that the fire is going to begin in a particular area of occupancy, then what we are trying to do is we try to contain the fire within that particular area of occupancy so that it does not spread to other parts of the building. But if you look at the main components or the main modes of fire protection, it includes passive protection, active protection and education. So, do you know what it means? It means that an ideal building is one which has active protection and passive protection in its place, so that in case of a fire, the fire can be contained to its point of origin, and through active protection systems, the fire can be cut down within the source itself. So, if we are to take a typical example, if let us say if we are to take the example of a data server room, the fire would begin in the data server room. We all know that because of all the kind of equipments and the equipments within that space. So, there is a high possibility of a fire fire hazard happening within a data server room. So, in such cases it is very important to enclose the data server room, or if you are to take a different example, let us look at an example of a. So, the other type of fire protection is called the passive protection system. Passive protection system involves attempts to contain and slow the spread of fire using fire resistant walls, floors and doors. Let me explain this to you with an example of a ICU in a hospital. Now, we know that an ICU in a hospital is a place where patients are kept under strict watch. Now, it is very difficult to move a patient from the ICU of an hospital outside in case there was a fire hazard in the hospital. So, it is very important to protect the hospital premises from fire spread. It is very important, let us say in the example of a bank or a hospital or a data server room, to make sure that the fire is contained within the place where it has originated. So passive protection system involves the use of glass in fire resistant walls, floors and doors. So if you are to take the typical example of any floor area, it would mean using fire resistant materials in the doors, in the walls and in the floors, so that there is no way the fire would spread to other parts of the building. So it's all about containing the fire in its place of origin. But if you look at the different components of fire protection, there are three. They are passive protection, active protection and education. Do you know what it means? It means that in any ideal living space, it is very important to ensure the best of both passive and active protection system. If you are to look at the same example of a hospital premises, it is very important to use fire resistant materials in the walls, floors and the door, so that the fire does not spread to different parts of the building. At the same time, it is important to have the right active protection system in place, so that when the fire originates, it can be killed at the source itself. Now, before we go forward in detail on the types or the different types of fire resistant glass, let us look at some of the common myths when it comes to the use and the application of these products. So, I will take you into some of the very common misconceptions most of them have regarding fire resistant glass. So, some of the common myths regarding fire resistant glass are that there are also a lot of other types of processed or value added glass that is generally available. Although they are not used for the fire resistant applications, each product finds its own application in different applications. So, it is not advised to use a product which is made to withstand impact loads, like let us say high thermal stress coefficient. It does not mean that these products can right away be used as a fire resistant glass. Actually, safety glass can only provide impact safety, or in other words, it only provides resistance to structural or physical stress. So, it does not mean that we can use any type of safety glass as a fire resistant glass. Also, I would like to give you another example of a tempered glass, which is only a safety glass because or it is called a safety glass because it breaks into small granules upon impact or upon temperature rise. So, in a way it cannot be related to a fire resistant glass, and it cannot be used in a place where one really needs to use a fire resistant glass. These are some of the common myths regarding FRG. I will take you into more details in the coming slides. The first myth that I am going to talk about is about how wired glass cannot be used as a fire resistant glass. It is a widely believed myth that wired glass is also a type of fire resistant glass. Wired glass is banned for use in a fire rated application because it has no impact resistance. A wired glass is generally an annealed glass with a thick wire mesh in between. So, it involves the manufacturing process itself involves float glass, annealed float glass coming out of the line, in which a wire mesh is fed into the raw glass which is in a molten state. So, there is no kind of value addition that is being added in terms of its strength or impact resistance. As a result, when someone uses a wired glass in a fire rated application, many times what happens is that it becomes very dangerous for the people in the vicinity, because as people egress through fire exits, there is a possibility that the victim's limbs can get entangled in the wire mesh, and it can cause a lot of damage and pain. And also, a wire resistant glass does not offer a clear vision. So, I will show you an image of a wired glass for your better understanding. So, what you see on the top, that is a wired glass. You can see you can notice the wire mesh which is being fed into the annealed glass. So, as a result, what happens is when you use such glass products in a door, and when someone is trying to open the door during a fire, which happens to be a high panic situation, there is a high possibility that the victim's limbs can get entangled in the wire mesh, and these are all annealed glasses which we are talking about. Annealed glasses per se do not have very low impact resistance. So, the glass just cracks and yields and makes way for the limbs to get entangled in the wire mesh, which can cause or which can put the victim in a lot of pain and damage. The other myth is that a typical toughened or a tempered glass can also be used as a fire resistant glass, which is not the case, because a tempered glass can only withstand a maximum temperature of 380 degrees C. So, and during a typical fire we observe that the temperatures can go up to 1200 degrees Celsius. So, if you were to look at it, the tempered glass would typically break 4 to 5 minutes into the inception of into the initiation of a fire, and also the resistance time of each tempered glass depends on what is the type of base glass that is used and what is the quality of the tempering and so many other parameters. So, the conclusion here is that a toughened glass can only provide a good impact safety. It can take impact loads, it breaks into small pieces, it does not cause any harm in case of any impact, but when it comes to fire resistance, a toughened glass is not the right choice of a product. So, in order to prove this point, I am going to be showing you a graph which will show you the which will plot the temperature rise in a glass against this chance of failure. So, here you see two graphs. I will take you through the graphs in detail. On the x axis, you see the temperature differential in the glass, which has been mentioned in degrees Celsius. So, it is in increments of 50 degrees Celsius, and on the y axis you see the chances of failures when there is a temperature differential. So, the temperature differential is the increase in the temperature of the glass before, after a fire, and during a fire and before the initiation of a fire. So, it is always going to be at room temperature for interior applications. So, as the temperature progresses during a fire, what are the chances that a typical normal tempered glass would break? Now, you see three curves in the graph. One curve is blue, which is the plot for a tempered glass when tempered without any polishing done on the edges. Against, you see a pink color curve in which the glass is cut, its edges are grounded in order to give it good stress concentration. And then the third type is the green curve, which is a glass which is cut, its edges are grounded, its edges are polished and then subjected to tempering. Now, if you look at the graph, it says that at the temperature differential of 100 degrees. So, let us say at the room temperature is going to be 25 degrees, and if there was a fire and if the temperature of the glass was about to reach 125 degrees, then there is a high possibility, there is close to 90% chance of the glass breaking in such cases. This is for, again, as I say, it is a low toughening stress. So, when a glass is toughened or subjected to a normal toughening process, by the time the temperature differential reaches 100 degrees, there is a high chance of the glass breakage. It says a 90% chance. Now, again, if you look at the high toughening stresses, again, if you were to look at the three different types of edge finishes that they have mentioned, you will observe that a ground and polished, that is a glass which is cut, the edges are grounded and the edges are polished and then subjected to very high toughening stress. Even at such high toughening stresses, the glass has a 100% chance of failure at around 280 to 300 degrees. So, which means that a normal tempered glass is bound to break at a temperature of close to 300 degrees, and it does not serve the purpose for when one starts using the same in a fire rated application. The next myth that I am going to be taking you through is a misconception that a double glaze unit can also be used in a fire rated application. the main reason of such a misconception is that is the fact that a double glazed unit comprises of two layers of glass being used. We all know what a double glazed unit is. It comprises of two pieces of glass which are combined to form a single unit with an air gap in between. So it's only bound to create a misconception that if you have two pieces of glass one behind the other, then the fire resistance of two glasses add up to each other, and then you achieve a greater fire resistance. But it is not the case. I will explain why. Because if you see the first crack in the fire side glass, so let us consider the example of double glazed unit. If there was a fire on one side, the first crack in the fire side glass will happen around 1 minute into the fire, and the glass particles will just fall off, because double glazed units use tempered glass, and we all saw in the previous slide that a tempered glass will break. If it's a low toughening stress, it will break at a temperature differential of 100 degrees. If it's a high toughening stress, then it will break at around 300 degrees. So give it 3 to 4 minutes. So if you look at a typical DGU, the first glass pane is going to break in 3 to 4 minutes, and the next glass pane will break immediately. That is because the hot air will pass through the second pane, and it will cause a thermal shock, which will cause a quick breakage of the second glass. So if you look at it, if the first glass breaks in say 4 minutes, then the second glass behind it will also break more or less within the same duration because of the thermal shock. I have a very nice animation to show you how it functions. So to explain why a double glazed unit cannot be used for fire rated application, here I have an animation of what a double glazed unit looks like. So it comprises of two layers of glass with a air gap in between. So it is only natural that people assume that if you have two layers of glass and if you have two layers of highly toughened glass, then the fire resistance of each will add up and you will obtain a higher fire resistance from the combined unit. But that is not the case. So let us take an example of the same, and let us assume if there was a fire on one side, so let us assume if there was a fire on one side and this one happens to be a tempered glass. There is a high possibility, or we know for sure, that if it is a low toughening stress, the glass will break at a temperature differential of 100 degrees, and if it is a high toughening stress, then the glass will break at a temperature differential of 200 to 300 degrees. So let us give it a maximum, let us give it a leeway, and let us say that it would break within 4 minutes into the fire. Now we assume, or it would be a common misconception, that the glass behind will also withstand for 4 minutes in case of the fire, but that is not the case. What happens is that when the first glass breaks, it lets a hot air gushing through to it into the second glass, and as a result the second glass will have a higher thermal stress, because all this while it was at a relatively lower temperature, and when there is hot air gushing after the breakage of the first glass, it is only a matter of 1 or 2 minutes when the second glass will also break. So as a result, you will only see that the whole system can withstand only for say roughly 5 to 6 minutes. So it is not advisable to recommend double glazed units for fire rated applications. The next misconception that I am going to take you through is the use of PVB laminated glass, which people believe qualify as a fire resistant glass, because at the end of the day it is a laminated glass and it is called or referred to as safety glass in the markets. But what people fail to understand is that a PVB laminated glass comprises of layers of polyvinyl butyl, which is sandwiched in between the layers of glass. As a result, what happens is that when someone the whole purpose of adding a layer of polyvinyl butyl in as a sandwich in between the two layers of glass is to make sure that if there is an impact on the glass, the broken glass pieces stick to this interlayer, thus avoiding injuries. So that is how the term safety glass was coined. But in the event of a fire, this can be a complete disadvantage, because a polyvinyl butyl is an organic layer and it will start burning. It is a combustible material. I have a very nice animation to take you through this. Let me show you that. So, what happens is, if you see on the left, you see an organic polymer interlayer between two layers of glass, and in the case of a fire, what happens is that the polymer in between starts to melt, and as a result and as a result of the heat buildup within the interlayer, and also because of the temperature differential, there is a high possibility that the glass will just explode and shatter, and also it will release a lot of volatile components which can be which can cause suffocation within an area of occupancy. So, you can imagine if someone was to use a safety glass, PVB interlayered impact safety glass. So, if someone was to use a PVB laminated glass, so you can see in the third case that during a fire there is a possibility that the molten interlayers can cause a temperature rise. At the same time, the temperature differential on the glass can cause it to shatter and explode. As a result, it can also release a lot of burning volatile, which can cause a lot suffocation to the people stuck in the vicinity of the PVB laminated glasses, which can be very dangerous and also cause a lot of panic during fire in any building. So, to conclude, the performance of glass is based on three criteria: thermal stresses, softening and thermal expansion. We just discussed thermal stress. It's when there is a temperature differential in the glass and it just starts to break or shatter into pieces. So, to conclude, the performance of a glass is based on three criteria. They are thermal stress, softening and thermal expansion. We discussed thermal stress, and we just saw examples of how glasses can shatter when they have a higher stress temperature differential. In some cases, this temperature differential does not cause an immediate breakage in glass, rather it causes something called softening. So, the glass starts to attain a viscoelastic state and starts to soften and flow down. And the third criteria, the third criteria on which a performance of a glass can be judged is definitely thermal expansion, because we are talking about close to 1200 degrees. So, there is bound to be a lot of expansion in the systems. Let's say a glass or the frame which holds the glass itself. So, due to the thermal stress phenomenon, a fire resistant glass, an annealed glass, a normal annealed glass will break at 45 seconds to 1 minute is what we saw. A tempered glass will break within 3 to 5 minutes, if you remember the graph that I showed you. Also, if you are looking at fire resistance applications which require fire resistant products, the rating that you generally require is 2 hours or 120 minutes. So, here we are talking about the use of the misuse of glass, which can only withstand 5 minutes of fire for applications which require up to 2 hours of fire protection. So the next part of the session is going to be about how specialty fire resistant glasses are classified, where they find application, what the norms are. But it's also interesting to know that a fire resistant glass can also offer other benefits which are very typically seen in the other value added products like a laminated glass or a tempered glass. Fire resistant glasses can also offer safety glazing properties, and also in addition to this, it can also offer you a tempered glass advantage, so that even if the glass was to withstand an impact load, it would still break into small shatters. So, it's at the end of the day, it's about finding the best of every other product and then combining it into a product which best suits the application.